Wow, notifications actually worked. Imagine that. Okay. So where do we begin today? So today we're going to be looking at this cable's killing me. So today we're going to be looking at an A1534 board that is dead. If you are familiar with these machines, a lot of them are dying for no reason, as is often the case when Apple releases new products. You know, they fix something one year and they break something the next. So there's a very common issue that happens with these machines. Even if they have not been liquid damaged, they have not been damaged by being dropped, water, misuse, overheating, gaming, none of that stuff, just poof, dies, and your money goes with it. So we're going to go over that very common problem today that affects the 820-00045 board and the A1534 12-inch MacBook. So let's just take a look at this little thing today. One of the first things you may notice when you take a look at this machine is that that board really has quite a bit more to do with an iPhone or an iPad than you can ever imagine it having to do with a MacBook. Look at the size of this board. It is smaller than my hand. So this is the size of my hand, and this is the size of the board. So if I pick this thing up, it is, look at that. Look at that little board. This is more an iPhone or an iPad. I'd say this is more of an iPad than it actually is a MacBook. So let's get started, and we're going to go over one of the very, very common problems that happens with this machine. And hopefully that's it, because if it isn't it, then the stream will become a nightmare on camera, which has happened quite a few times with these newer machines, and that's never any fun. So I'm going to put this machine over here on the shelf so that we can get started. TCRS says I hate these. Well, trust me, man, I do too. Also, by the way, I have been shilling my Moto review, and some people have asked why it has not been published yet. According to my laptop, it has 8 hours and 39 minutes of rendering to go, so that's going to be a while. So let's get my multimeter program on and get that on screen here. Zoink. Whoops. All right, let's see why. Show me my meter. Here we go. Get my ad on there. And my meter is totally miscropped. So we're going to fix that real quick before beginning, because that's going to drive me nuts. Let's see. Is it like that on all? Let's get the microscope camera on here. And here. There we go. It works in the view that matters. All right. So let's go over this machine here. So there's typically a page that's going to list every single power rail. And we're going to find that and go over a rail that's very commonly missing. We just got to find the page that lists every single rail. Why are they so awful? It's a good question. Why are these machines so awful? Hello. Yeah? Oh, here we go. Okay, so we've got a list of all the power rails that we should expect to have on this machine. And it looks very similar to the older ones. You got PP Bus G3 Hot, PP-DC-in G3 hot, which is 20 volts. We've got PP3V3 G3 hot, PP3V3 R3V0 AON. This seems like a new power state. This is a state that we haven't seen before. AON. Does anybody want to guess what AON may mean when it comes to a power state? A power state is the time during which you would expect that rail to be on. So an S5 rail would be on when the machine is in an S5 state, S4 rail would be on when the machine's in an S4 state, and so on and so forth. So what do the Mensa members in my chat think that AON means? Don't give anybody a hint, Paul. Let's see. Always on. That is good. That's the closest guess that I would have. That is exactly what I would guess. You hush, multimeter. My multimeter wants some attention there. So, let's see. So that would be always on. So we're going to check some of these rails. We're going to check what happens right around here. So as you can see, this is my board view software, and this is the DC-in board. So let's go and yoink you out of there. So this is the board. This is the DC-in cable. This is where the charger is going to plug in, and it goes right over here. So if we look at that on the board view software, you'll see that this leads to a fuse F4700. Now, if we look that up in the schematic, F4700 is going to the charging port, and that's where the main power line is going to be going to the computer. That's PP-DC-in E85, and as you can see here, it says that this rail we expect would be 20 volts. So let's see if we're getting 20 volts there like we are supposed to. So I'm going to keep this lovely software on that allows you to see the camera and all that good stuff in the multimeter, and move this over. And I got to redo my scenes and shortcuts in Open Broadcaster, but that can be done another time. We're going to plug this thing in. I hate the DC-in boards on this. I'm not quite sure if you've all seen these things, but see this? Like, it's not one piece. It's a flex cable that snaps onto the port. This is one of those things where I think it would be nice if it was one piece, or at least had a screw thing over here, because it's really easy for this thing to fall off. It's, yeah, let's see if, see, this is somewhat aggravating, because this is always going to fall off while you're testing it. Typically, I surround it with a little bit of tape, which I actually might do now if I can find some Captain tape. Here we go. Got some nice Captain tape over here, and I'm going to tape that together so it stops driving me nuts. You have a Doge and a cool Pepe on the back of your chair. Do I? Oh, that's Steve. Steve put a Doge on the back of my chair. Paul put the Pepe there, but Steve put the Doge there. That is not financial advice. I do not suggest that you buy a Dogecoin. I may or may not start paying Paul in Dogecoin. I may or may not be working by myself tomorrow. All right, so that makes testing more easy. Keeps me sane. So we're going to plug that in. Now take a look at what we get on the fuse. What voltage do we get on the fuse? So black probe on the ground. And let's make sure that's all in focus for you. Hope everybody's been having a good day, good time. And it looks like we get software. It'd be nice if you refreshed any time now. You're stuck on 1.8. Boo. B and K, you're killing me with this crappy software. Ah, Jesus Christ, this is terrible software. B and K should be ashamed of themselves. Oh my God, this is dumb. Okay, so you're just gonna have to deal with the fact that there's a bunch of random stuff in the window. B and K, this meter was $160, and I linked to it. Can you do me a favor and write me some software that's worth a damn? Anyway, so we have 5.2 volts. I'm not sure if you can read that because this software is so dumb that it picks up what is under the software when you turn it on. But we are getting 5.2 volts there, and as you can see over here, we're supposed to be getting something closer to 20 volts. PPDC in E85 SS is a line that's supposed to be 20 volts. Now, let's see. What is going to cause something like this to happen? So if we were to go this charger, this USB-C charger can put out different voltages. It's not like a standard MacBook charger where you only get 18 volts or 0. The USB-C is designed to work at multiple different voltages. It's supposed to work in different ways, unlike this B&K multimeter software, which doesn't work anyway. It's just a piece of Windows 95 design garbage. Oh my God. I can't believe I paid $160 for this. This is so painful. This entire thing is such a buggy pile of... What happened to the old multimeter and plug-in thing? That thing permanently died, so that's junk now. That stopped working altogether with any computer, and I got another one and it did the same thing, so we're done with that one. So let's check out the rest of what's going on here. So we have communication. There is communication with this charger. It's not just standard one-wire communication either. You've got USB 3, DisplayPort, all different types of talking is being done over here. So what is going to be handling most of the communication? Now, in the older machines, the ISL 66259 dealt with the charger. Let's see what the ISL and the SMC did that. Let's see what the ISL 95530. This is the U7100. This is the buck converter for the charger. The main question is, will it get fan spin? This machine has no fan! So that is blasphemy. And that is some... What do you have? Leprosy B&K? Seriously? Look at this B&K. Look at this piece of... It looks like it has leprosy. Oh my God. What a terrible, terrible piece of software. Wow. Okay, there we go. Don't touch it. Don't touch it. It's... But did it freeze? Ugh. Oh man. There we go. Okay. All right. So we got that there. Now, this chip, U7100, let's see if this has any relation to any other rails. PP3V3 R3V0 AON. Seems like something that would come out of U7100. So let's check this power line here. PP3V3 R3V0 AON. Now that power line is on my list. So we've got DC in. We already have that. We have the PP bus. Let's see what PP bus G3 hot is. Let's see what that is. That's a common one. Okay, we're going to get that on this big capacitor over here. So let's measure that big capacitor over here. 109 millivolts. So that's not present. Well, I'm curious if we have a short circuit on that rail. So we're going to unplug this and check the multimeter on ohms mode. 4 million ohms is what I get, and it doesn't show on the screen because B&K software is useless garbage. I expect junk when I pay a little amount of money, but getting junk when you pay a lot of money is painful. No mercy on B&K for that. There's no excuse for that. So let's check PP3V3, G3 hot next. Now remember, on standard MacBooks, PP3V42 needs to show up before PP bus G3 hot. But there is no PP3V42 on this list. So there's going to be a new rail that most likely achieves the same function. Jellycomb. Yep. That's... So let's see if we have a short to ground on PP3V3. 12.84 kilo ohms. And hey, look, it showed up. It only had a 3-second lag. Great job. 11.2 millivolts, not there. Let's check PP3V3 R3V0 AON. Now, I'm going to take a wild guess that AON, this whole always-on thing, is important. And dare I say it, may even be above G3 hot. Not sure. But there's really only one way to find out. Let's see what's going on with that rail. Let's find it on the diagram and go from there. PP3V3R Revo. 3-point volts Revo. That's what I'm going to call it. All right, so we're going to find it under this little PMIC looking whatever the hell that is. Not quite even sure. And let's measure voltage that we get. We're supposed to be getting 3.3 volts, and it looks like we're getting 2.141 volts. Now that's an interesting one. Why are we getting, because that's not zero. 2.141 volts is not a valid state, is it, Doge? Doge says no. So that's not really a valid state. We should be getting something like 0 volts if it's failed, or 3.3 volts if it works. 2.1 volts tells me that it's trying to create that, but either the chip that creates it has failed, or it's being pulled down by a short circuit to ground. So let's try and figure out which of those two possibilities it is. So we're going to unplug that, and we're going to check and see if we have a short circuit to ground at that point. Well, do you think this would be like 1V8 always on the iPhone? Perhaps. I think my theory is that PP3V3 Revo is the recreation of PP3V42 from the older machines. Oh, that's on voltage, not ohms stuff. All right, so let's put it back to ohms mode, and it looks like we have 39 ohms to ground. Now, do keep in mind that a low impedance to ground is something that you would come to expect, particularly on a low voltage rail. So, for example, if you were to measure the resistance to ground on a CPU buck converter, you would expect that to be a low resistance to ground. A CPU uses 25 to 60 watts of power, and it does so at usually 0.7 to 1.7 volts. So if you do the math with Ohm's law, you need a really low resistance for that to happen. And at 3.3 volts, I would expect a lower resistance to ground, but I would not expect this low resistance to ground. 3.3 volts at 67 ohms doesn't sound right to me. So let's see if anything gets warm on this board. Now, I am going to give this thing another chance because Paul has been saying I should give it another chance. We're going to use the short detecting thingy again. And in the interest of full disclosure, I was never paid to review this, which is why I gave it 2 steaming pile of thumbs down reviews in the past. Well, that's not why I did that, because it's $900 for a thermal camera that has no zoom. But Paul has been speaking well of it since it helped him on one, so we're going to take a look and see if that thing can find anything that has failed. So we're going to check this out. Let's go over, and first thing we're going to do on the board view, what's up, Moot, is we're going to look for every area that PP3V3 Revo may be present on. So I'm going to full screen this. That's the wrong thing to full screen. And let's minimize this stuff and get that off of here. And we're going to put the board view software. Here we go. We're going to full screen the board view software. And over here, Landrex full screen, baby. So, open board view. I'm sorry, Paul Daniels, I didn't mean that. All right. So what we see here is it's showing us every single section that it's going to show us every single area where we would expect 3.3 volts to show up on this side and also on the other side. How long could I can't sing, but I got that now. I got that song stuck in my head. But you could see these are all the possibilities. So if we have a short circuit to ground, that means that one of the chips that you see is the chip that is dragging that voltage to ground. So we have to figure out which one of those chips that is. So I would expect one of those chips to get hot, and whichever one gets hot is probably the one that is to blame. So we're going to open up this thermal cam imaging mess of a software and see how this thing works. So let's get this set up, and here we go. Oh boy, that looks all right. So now keep in mind, these are all the sections. I'm going to put that on the screen up here. So on the left, these are all the sections that could possibly be shorted, and we're going to put that under this thermal camera and see if it finds whatever's wrong. And we're going to use a new little feature of this thermal software imaging thing. All right, so let's go on the top side of the board. Now, let's see. Now, there's this button that I haven't been using, and the reason I haven't used this button is because it's in Chinese. So, see, this little button, it does something where it gets rid of all the sections of the board that aren't hotter than the rest. It gets rid of the coldest sections of the board. And again, one of the reasons I haven't ever clicked this button is because I don't know what it says, because the software comes in Chinese, even though it costs $900. Thanks. Anyway, so if we move around the board, you'll see that we get to this one area where the rest of the board is 26, 25, 27 Celsius, but right over here is 31 Celsius. And let's take a look and see if that also passes the alcohol test underneath the microscope. So let's go over to the microscope and see what that thing is. I got to get a hotkey to turn off the multimeter. Would you hire someone with no skills to solder 70 nanometer wires to a 2x2 millimeter substrate? I don't think so. How many Dogecoin do you own? More than you. That's my #1 currency, man. It's my favorite currency. Dogecoin. Alright, so we've got some power going to the board. Let's take a look in that area. Ooh. And as you can see, this is evaporating first. So we're going to take that off and see if after we take that off, if we get any different results. The first thing we're going to do before we do that is unplug it, because we don't plug in boards here while we're soldering. That's totally never happened before, even by accident. Professional. Right, Paul?
I did that on my interview.
Oh, yeah. It's a good thing your microphone is off. All right, so we go around here. Let's take that thing off. Moot says Doge is better than Bitcoin for 2018. Damn straight. What's your opinion on the 12-inch Retina? Besides the fact that it has a number of random failures, that the SSD is soldered onto the board, it costs a ridiculous amount of money for fairly poor specifications. It randomly fails and and it has one port. It has a cloaca. Besides all of that, it's not a bad machine. You know, if you don't consider price, performance, durability, or usability, then it's a great computer. Other than that, it's kind of shit. I meant poop. I meant dough. I would sooner spend $1,300 on Dogecoin than I would on an A1534. Doge by far. Alright, so we're going to put those shields around this because this is like an iPhone board and it's very sensitive to heat, especially in the areas next door since we have some important items next door. So we're going to heat using this quick 861DW. Get yours on store.rossmangroup.com. Don't delay. Buy today. A little bit of flux there. Would you consider reselling ThinkPad parts? Honestly, I'm at a point where I must be insane to be reselling MacBook parts since there's virtually no profit in it and fairly low volume. So I don't think reselling ThinkPad parts would be a good idea for me. I'm only selling those because I want to kind of have a one-stop shop for the people that buy other stuff from me. But we'll see. So the chip is gone. So now we're going to replace that chip with a superior one. A superior one. Now, if you needed to find a superior chip, Paul, where would you go? That's right. Hey! Let's start. You would go If you wanted that quality chip, the place that you would go to get it is the place. Ahem. Ahem. Oh, no screen capture. You would go to store.rossmangroup.com and use the search bar, type in U4700, and automatically it'll show you the chip that you need. It'll tell you exactly which ones it's compatible with. It'll even tell you the most common cause of failure if this chip has not worked. It'll show you compatible boards, and best of all, same-day shipping from New York City. Store.rossmangroup.com, the best place to get your USB-C communication ICs, aka U4700. Now back to our regularly scheduled programming. So now we're going to replace that IC chip and see if that fixes our problem. And let's... We can get rid of those shields now for the time being. This board is so light that you may actually need to use a board holder for it, like you do with iPhones. You really are a Boy Scout. The moment I said that, a board holder just showed up on my desk. Did I just create that huge bridge? Whoops. Do you ship to Canada? Absolutely. We ship to all the countries that Jessa doesn't. Have you considered using a bot for Twitch? I haven't, just because I haven't had the time to set it up. I honestly haven't even done a good job of setting up the links. Like, when I look at other people's Twitch pages, they look awesome, and they have all this stuff set up really nicely, and mine looks like complete junk because I set it up myself. So, I haven't put as much time into Twitch because usually I have, 5 concurrent viewers. So there has been a little bit more effort put into the YouTube. I'm practicing my shilling voice by doing manual shilling. So, pin 1 is in the upper right corner, so I would expect that the dot goes in the upper right corner. Now let's just find my chips. Of course I know exactly where they are, because I am store.rossmangroup.com. That would be something if I couldn't find my own chips. Usually they get eaten by the air filter. Grr. Here we go, folks. Anybody have experience replacing the keycaps in the 12-inch Retina? Honestly, no. I've never been good at that. I've never had a motivation to get good at doing that. Because it's one of those things where you could spend 10 to 20 minutes doing it. It's incredibly aggravating and frustrating. And people are like, great, you did that. Here's $3. Or nothing. So I never really had, and I also sucked at it. But I never really had a motivation or incentive to figure it out. But I know that the 12-inch one is considerably more of a pain in the ass than the older one. And the older one was a pain as it was. So no fun. We're just going to go around the sides of that chip and make sure that everything's soldered nicely and properly. Lewis, the store.rossmangroup.com accept Dogecoin. We're working on it. We're working on it. I would love for Dogecoin to be the preferred currency of store.rossmangroup.com. It's already the preferred payroll currency of rossmangroup.com. Paul hasn't checked his paycheck yet. All right, so that's our new chip. We're going to give it a second to cool off first. You don't want to overheat that chip. You just admitted that your motivation and incentive is money. Well, duh. It's either money or happiness, and there's no happiness in replacing keycaps, so it's got to be money. There's genuinely no happiness in replacing keycaps. That is no fun. That is utterly miserable. That's just, it sucks. It's awful. Okay, let's see. Yeah. Like, there's some stuff that's fun and investigative. There's a lot of stuff that can be fun and interesting, but that sucks. There's no fun in that. Okay. Let's see if I get 20 volts now. Do I get 20 volts in my little retina? We just did a data recovery paid in Dogecoin, says Jessa. You did a Dogecoin recovery and you didn't tell me? Oh, man. Do we get 20? Oh, 20 volts, baby. We're set. We're done. There's no fan spin on this board because this board has no fan. So check out. Huh?
Is the light on?
Is there a light?
Yeah, the system detect light.
Where's that?
Right next to the battery connector. Little LED.
There's a... Huh? Don't shock me.
Right there.
That's barely...
Yeah, it barely comes on, but...
that's really nothing. That's dead. What I do is I check CPU vCore.
Well,
so
here.
CPU vCore is 21st century fan spin.
Turn that back off?
Yeah.
Yeah,
Oh, really? Wait, plug it in. Let me see.
Yeah.
That's a light?
That's a light.
You're kidding me.
Yeah.
That's bull. I don't think anybody could even see that.
It's easier when it's in the case.
That's the way they test. That's the way they expect me to tell if this thing is on. All right, so
It still doesn't tell you if it's on, though, but it tells you if it has power.
All right, so what I'm going to do is I'm going to check for CPU vCore, and see. If I get CPU vCore, I consider this as on. All right, so let's see. PPVCC SO CPU is right here, so that is the new version of fan spin, baby. So let's see what we get by that capacitor. That appears to be next to the CPU on the bottom side of the board. And I bet that I do got myself some fan spin. Fan spin. Here we are. Yes. This is going to be some beautiful fan spin. Fan spin without a fan spin, I say. .5 volts. Well, that's that. That's that. That's 21st century fan spin, and that is how you fix the most common issue facing the 820-00045 retina. U4700 dies, and it shorts to ground. But it doesn't do a full short to ground. It does somewhere between a 33 to 67 ohm short to ground. Now what I'd like to do is I'd like to measure the resistance to grounds we get on that rail when it works, just so that you have a working comparison. So let's go back here and see what we get. So I just unplugged the power supply. We're in ohms mode on the meter, and let's see what you get for PP3V3 when there is no short and the machine is working properly. So what you should be getting is something around... Oh, come on. Come on, show up on screen, you. Show up on screen. Oh, you piece of work software. I have so much rage for B and K right now. I have to restart the software every 5 minutes. So we're getting 8.6 kiloohms, and I'm just going to leave it there until it gets the exact number. And it looks like 8.6 kiloohms is it. So on these machines, the most common failure, according to Dogecoin back there, is that U4700 fails. It fails by shorting to ground PP3V3 REVO _ always on by making it between 30 to 60 something ohms, and it's supposed to be somewhere above 8 kilo ohms. U4700 is what shorts the ground. You can find U4700 on store.rostengroup.com. The symptoms of this issue will be that on the DC input fuse, you'll be getting 5 volts instead of 20. Before that rail is present, all of the ICs that allow the charger to talk to the computer, all the ICs that do the communication with the charger are dead. So the charger is not able to negotiate the 20 volts. It stays stuck at 5. So the DC in, you'll be getting 5 volts instead of 20. And typically that's because PP3V3 R3VO is missing. And now if we go on to the schematic area over here, I can show you all the chips that are powered by that. We could kind of scroll around, take a tour. So let's take a tour and see what is powered by this before we finish for the day. I hope that LED is lit when it's in the case. Barely. Any hint for A1398, battery okay, boots, detects battery, can detect charger is connected, charger has no light, does not charge. I have at least 20 videos on that, and I would suggest finding them. Your issue may be Q7180 is dead, one-wire circuit bad, current sensing bad, no way it needs... Yeah, that there's no information there that I could use to diagnose your problem, I'm afraid. We do have videos on how to do that. Anyway, so back to our regularly scheduled programming. PP3V3 R3VO pulls up several signals. It pulls up these... Let's see, what is this thing that it pulls up? Let me zoom in. I'm getting old. I'm going to be 30 this year, so I have to zoom in on things now. E85 SMUX debug, E85 low speed MUX something something, E85 low speed MUX debug. What else is that for? It pulls up a signal called high power management, something power management reset, so it pulls that up. It powers U4780, which is USB VBus charger detection. So hint, hint, this sounds important. This chip is for charger detection, and it will not turn on if it doesn't have this rail. PP3V3 R3VO powers U4700. This is the chip that we replaced. And this is for... let's see, there's some talking going on. I see Miso and Mosi. The Miso and Mosi is discussion. And let's see, bidirectional. So this is some type of bidirectional line, E85, so it's probably talking to the charger. HPM master bus. So this is where the charger detector is going to talk to the high power management. It goes to the battery. This is responsible for, and it comes out of the ISL. This is responsible for everything. So all the communication that the charger does... Somebody's sabotaging my video by crumbling. There's all this noise. No, it's all these chips that are powered off of this PP3V3 rail are responsible for talking to the charger, or muxing of some sort. Let's just zoom out and get a better view of that. This page is the fun one. Look at this. Oh my God. So you have this talking to this, talking to this, talking to this, talking to this, talking to this. If somebody says that my USB items don't work, oh my God, this is going to be a fun machine to work on. What are you supposed to tell somebody if somebody comes in and says my USB 3 devices are working but not USB 2 devices, and you look at this, Paul, what are you going to tell them?
Oh, well, that's handled by the center pins on the USB-C. That might be fixable.
Oh, this is such a, oh my God. This is the price of having one port for everything.
Ugh,
Jesus. I know. So that's that. That's everything for today. And as always, I hope that you learned something. And I'm going to be releasing my videos shortly on the Moto. As you can see, we are still rendering. Here, let's see if I can get you to see this on the camera. So, all right, this is my laptop. This is rendering my video review of the Moto. It has been rendering for 1 hour and 28 minutes, and we are 16% done with 7 hours and 24 minutes remaining. So that is going to be a while, but I will be excited to upload that. We've got all sorts of fun stuff in that review. We've got signal strength, camera quality, camcorder quality, noise cancellation, charging speed, build quality, all sorts of stuff. So that's it for today, and I'll see you next time.